Greetings and welcome, friends. Today is everybody's favorite day in geometry because it's not really geometry, it's algebra. Although I suppose I haven't looked at the statistics, but sometimes people love algebra and hate geometry, or vice versa. Sometimes you might be excellent at one in your aptitude to learn it, and then the other takes a little bit more effort. But today, it's just like you woke up, and you're in algebra now, and we get to do easy stuff. This is great. However, beware. Behind this is a principle that's being applied where I'm teaching you a concept with something that is familiar to you, so that then you can apply this new procedure to things that will be less familiar to you. So if you're just like, I know algebra, that actually would be dangerous. I'm teaching you something new in the format in which we do this. So let's see, using algebraic properties of equality. When you solve an equation, man, I love solving equations, you use properties of real numbers. Segment lengths and angle measures are real numbers. Did you guys notice that? I noticed that. Actually, they're a subset of the real numbers. They're like the non-negatives, I guess. Yeah. So you can also use these properties to write logical arguments about geometric figures. Here are some properties of equality. Right? Algebraic properties of equality. Let A, B, and C be real numbers. So here's the idea. I can add a number to both sides of an equation and it maintains its equality. Cha-ching, right? I can subtract a number from both sides of an equation and it maintains its equality. Cha-ching. I can multiply both sides by a number of an equation, right? Both sides, and it maintains its equality. And here it just says C is not equal to 0, because that's actually just wouldn't be very interesting. You just get 0 equals 0. And it's like, what are you doing with your time? I could divide both sides of an equation by the same thing, and it maintains its equality. And here C definitely cannot equal 0. Why is that, friends? Why can't C equal 0 there? Well, I don't know if you guys remember this, but you can't divide by 0. That kind of like our universe falls apart if you do that. There was an episode of Flash about that, actually, and he had to stop the guy from dividing by 0. It was crazy. I made that. Maybe that was my fan fiction, the one that I wrote. Check out my blog. It's called Waddy Flash at blogspot.com or something. No, I've never really watched any. My wife has watched it, and I've been in the vicinity of Flash happening. So let's see. Substitution property of equality. Oh, this one I call the classic Indiana Jones property. That's what I call it. Yeah, that's what I call it. Because if you remember, I'm wondering whether or not I actually want to add. Let's see. Let's do this. Let's do this. Tell you what. Indiana Jones property. Let's add a video capture device. Sure, that sounds great. Oh, here we go. Oh man, my hair is way too slick looking today. All right, so you guys can't see me, but the internet can. Here we go. See, right. So here my students in real life. You guys can look at me for a second. I guess I still need my mic. So Indiana Jones, you might remember, right? The very first film, Raiders of the Lost Ark. He had this thing where he snuck into this cool temple, right? This cave, and there were all these traps. And he had these buddies with him that were helping him, and in this cave, he came to this room, and there was tiles on the floor, and he had to not step on the right tiles because thunk thunk spears would shoot up from them. And he gets to this pedestal. Let's say this is the pedestal here. All right, and on the pedestal was a golden idol. Do you guys remember this? Have you ever seen this? Maybe not. Okay, and then he's all there's been traps up to this point. It would be reasonable to assume that I can't just yoink steal this golden idol. There's probably a trap associated with it. And so he's got this bag of sand that he had filled with sand prior. And then he's all you see him, it's in his eyes. He calculates the molecular weight of gold compared to sand and calculates the number of moles in the volume of that. It happened. It's in the script. You can see it. And then he takes something that, actually better yet, two things that were roughly, in his calculation, equal in weight, And then he does this. And he substitutes, right? Substitution property. Indiana Jones property. I just got so many eye rolls. This is so great. But the idea is that, right, if these two things were truly equal, he could swap them out, and it's a legal, permissible move. And that's the same thing with algebra, as you can see right over here. I actually have to like point in the opposite direction. Right? If A equals B, then A can be substituted for B in any equation or expression. I can swap them out. Also, no spoilers. I won't tell you what happened with Indiana Jones. Yeah, like, yeah. A rock chases him. Probably so. Yep. So anyways, I'm going to wave bye, so bye video. All right, I'm going to remove that. Yes, bam. Okay, back to this. Excellent. So that's a substitution property. You can swap those things out at any time. Indiana Jones, now you'll always remember it. But you probably already remembered it, so I just took a lot of time to explain something you already knew. But it made me feel great about myself, and really, that's why we're all here, right? Like, this is just like a made-up career that you guys have allowed me to have, where I can just feel good about myself by explaining math to people. So I appreciate it. This is like an intervention. So here we go. Here's an algebraic equation, and then they added this one piece where they said justify each step. So I'm going to have over here will be my reasons, all right, and over here will be kind of like my statements, all right, statements. And I'm going to set it up in this kind of two-column fashion, which we will call like a two-column proof tomorrow, but shh, no spoilers. So let's see. I'm going to rewrite the original thing. So I'm going to write 3x plus 2 equals 23 minus 4x. The reason that's true, why is that true? It's true because they told me it was true. A perfectly legitimate reason is given, right? That the people who wrote the problem told me that 3x plus 2 was equal to 23 minus 4x. But now how could I solve for x if I want to, which is what they also told me to do? Oh. All right, so add 4x to both sides. We'll let Ryan get in there this next time. So slow down. What allows me to add 4x to both sides? That's why you're doing it, but why is it true? Yeah, addition, add prop, equal. All right, look at my shorthand notation. I love it. So addition property of equality, I can add the same thing to both sides and it maintains its equality. So I've got 7x plus 2 equals 23. And now Ryan is telling me subtract dose from both sides, which I agree. What allows me to make that move? Subtraction property. Man, there we go. Of equality. All right, and when you abbreviate subtraction, you got to go out at least as far as the t, because it might be confused with substitution property of equality. So, right, enough characters that it will be unique. Yeah, 21. 23 minus 2 is 21. And let's see, Phoebe, what are your thoughts as far as what I might do next to solve for x? Man, isn't this great? Like, what if this was just what we got to do for the rest of the course? So I get x equals 3. And Holden, why do you think that I'm allowed to do that? Because of division what? That's right, division property of equality. So I have just been able to justify my steps. I've been able to give reasons the whole time as to why that is true. Right, so you guys already knew how to solve, and now we're just getting used to this idea of a format of making statements and reasons. Here's another property for you. Distributive property, in which I can distribute multiplication by a number over addition or subtraction, in fact. Question, comment, observation? No, or are you just stretching? He's stretching. All right. So distributive property, also Another type of distributive property is exponents can be distributed over multiplication or division. I don't know if you guys knew that. Did you know that? But super illegal, non-distributive property, exponents cannot be distributed over addition or subtraction. Super illegal. Classic mistake right here. Oh, no. Yeah, can't do that. Oh, how silly of us. So let's do an algebra problem with, and you can probably guess it. Probably the distributive property is going to be in this one as a reason. It's kind of like in video games when like you get a whole bunch of health packs and like ammunition, and you're like, "There's probably a boss fight coming, isn't there?" And you're right. You're absolutely right. Okay, so let's set up my columns. I'll just do this. Bam. I'm not going to draw the across the top crossbar there. All right, so step one. Common error is that people don't include the minus sign when distributing, which also, that's what I call distribution sometimes. So let's see, I'd have negative 35w minus 40 equals 30. Now, why is that true, friends? Right, those were not like terms, so I couldn't combine them in that form, I agree. And the reason this was permissible is the distributive property. Distributive property. Let's see. And then to solve, let's see, Liam, what do you think I do next? I like it. I like it. And the reason that's true, Liam, why do you think? Man, pretty easy. It's a little bit annoying, like needing to be so accurate, but it's true. Equals 70. And let's see, Holden, what are you thinking I could do this time? Am I gonna like add 35 to both sides? Yeah. And that's, why is that true? Man, I couldn't even fool her with the classic add 35. That's a classic one right there. So yeah, division property of equality. W equals what? Negative 2. I like it. Done. And I could if I was like doing some sort of a check or something like that. Yeah. But at this point I haven't, and it's not requiring it. But yeah, that a check is, you're right, an application of the substitution property. All right, guys, here's the realest of life problems. Here we go. You get a raise at your part-time job. About time. To write your raise as a percent, use the formula P times R plus 1 is equal to N, where P is your previous wage, so that's what I was getting paid per hour. R is the percent increase as a decimal, so if it was like 3%, that'd be like 0.03. Why do I have the plus 1 here, do you think? Because it's going up. If I just multiplied P times, say, 0.03, that means I now am only getting 3% of my original wage, and that would have been a 97% decrease. I want like 103% plus the 3. Yeah. So that's why that plus 1 is there, that we're adding 1 to the 0.03 first, or whatever the number is. Is it 0.03? I hope I didn't like randomly guess. No, it isn't. Whew. All right. We negotiated even better, by the way. That's how good I am at negotiation. And N is your new wage. Solve the formula for R. So let's see. P times R plus 1 is equal to N yay. All right. And they asked me to solve the formula for R. So I'm actually not going to plug in any numbers yet. I'm going to solve this treating everything other than R as though it is a number. All right. Because variables represent numbers anyway. So how could I get R by itself? Thoughts? Yes. I'd subtract 1 from both sides? Okay, I could distribute first. You could also divide both sides by the p. My undo just undid more than I wanted. So let's see. I'll distribute first. I think you guys are rooting for distribution. There's multiple ways you could do it. So I'd have PR plus p times 1 is p and equals n. Now how do I get r by itself? Oh, also, what property made that permissible? The distributive property. I like it. I like it. Subtract a p from both sides. Now, n and p are both going to represent numbers, but right now I don't know what those are, so I'm just going to write that as n minus p because those aren't like terms like Ryan was talking about earlier. So PR is equal to n minus padre. And now what could I do to solve for r? Oh, that was, man, I keep forgetting to justify. That was subtraction, by the way. Well, I'm trying to get r by itself. Yeah, just the p. And I could write all over p here, or I could do n over p and p over p. There's a couple ways you could set that up. I don't know. We'll do all over. Yeah, the p over p would be 1 in that case. And the reason that's true was div prop equal. And these p's would cancel out. I'd get r is equal to n minus p all over p. So here's a formula solved for r, and I justified it. And then they asked, what is your raise written as a percent when your hourly wage increases from $7.25 to $7.54? So my P is going to equal 7.25. N is going to equal 754. And if I am plugging this in for Padre here, and I'm plugging this in for Enye over there, what property allows me to make that move? Oh yeah, that's substitution. And bless you, 7.54 minus 7.25 over 7.25. The reason this is true is subs prop equal. All right. And then I just simplify using order of operations, which is also what that's a legitimate reason, by the way, simplify. And you guys were getting r equals like 0.29 over 7.25, and then divide, you get r equals 0.04. And then what does that mean? That's a 4% raise. Oh, man. Yeah, still getting paid under the minimum wage. What is the new minimum? $9.60. Wow. That sounds like so much monies, but I know it's, yeah. Yeah, Uncle Sam, man. Uncle Sam. I filed my taxes the other day, and then it got kicked back, and they were like, you gave us a social security number for a dependent that is not existent. And so, like, it's like I was creating people so I could claim them as dependents. The dependent was my son, who we adopted last year, but we forgot to change his social security number. But legally, his name is different now. And so now we've just got to call social security, because right now they're all like, this person doesn't exist. Like, you can't claim them as a dependent. And I'm all like, I guess that makes sense. That's on us. So we'll figure it out. It's not like I committed fraud, but they might think that for the moment. Yeah. Yeah. Did I just, like, admit to... I don't know. It's going to be on the internet. Yeah, I'll edit that out. But it's not like I read his full legal name and his social security number. That would be foolish. Whoa, come on, Liam. That's not the friendliest. Here we go. I copied something up, and then I didn't even read it. I was just talking about Social Security. Other properties of equality are true for real numbers, and segments and angle measures are real numbers, so these properties apply to geometria. Reflexive property, anything is equal to itself. This is like the best one, right? Oh man, reflexive property. And that works for segments too. Segment AB's length is equal to segment AB's length. I love it. Isn't it great? I feel like I'd want to, in like any sort of debate, interject reflexive property in the middle of it for no reason. And it's like, well, yes, the reflexive property is true, but that doesn't help your case. I think you're missing what I'm trying to say here. Symmetric property is like if I have symmetry, if I mirrored this over the equal sign, if A equals B, then B equals A. That also works for segment lengths or angle measures. And then transitive property, that one, man, classic, right? If A equals B and B equals C, then I can just cut out the middleman. Let's just say, hey, A equals C, friend. And transitive, I like to think about a train of equality, right? Chugga, 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 chugga. Did you just say Coltrane? Oh, I was thinking Coltrane of like Gears of War fame, but there you go. So there's some properties. Let's do a slightly more geometric justification. And this will be where it gets a little bit more interesting. Let's see. I've got to at least do this one. Man, I want to get to example 5 too. We'll see. All right, Mr. Waddy, you gotta talk faster here. All right, how am I doing for time? 20. All right. You reflect the beam of a spotlight off a mirror lying flat on a stage as shown. Determine whether the measure of angle DBA is equal to the measure of angle EBC. Now, we'll check this out. DBA is El Grande angle, and EBC is El Otro Grande angle. Muy caliente. Actually, one time I told a student to I said to my class, siéntate en sus asientos, which means to sit in your seats or your desks or whatever. And a student thought I said like muy caliente, and I was like, no, no, that is not what I said. No, because yes, that would be weird. So let's see. Let's see if we can make some claims about this. I'm going to set up some statements and reasons. Okay, that's a great statement to start with. All right, so statement 1, we said, well, actually, I'll start even before that. Measure of angle 1 is equal to measure of angle 3. And the reason that's true, like they told us. I don't know, like it's not on me. It's called given, right? That's like the best reason. Okay, how about this one? Now, I want to make a claim about the large blue arc. So I'm going to say the measure of angle DBA is going to equal the measure of angles what plus what? Yeah, 2 and 3. Why is that true? Now, when it comes to reasons, we can reference any postulate, theorem, definition, or property. Do you remember that's true? Angle addition postulate. Yeah. So that's true because of that, for sure. And for a similar reason, actually, there's multiple ways you could write your proof, by the way. I'm going to make a similar claim about EBC. Measure of angle EBC. What do you think my angle addition also ditto marks? What 2 angles would I write here? What 2 measures of angles, rather? Okay, so that's true because of angle addition postulate. Now, do you guys see a way that I could combine these statements into something that will help me? Wait, we're not there yet. We're not there yet. But what if I did this? If these 2 things are equal, I can substitute them at any time. So I'm going to make a new statement, say the measure of angle DBA And that's, here we go. dBA is equal to, so this new statement is going to be measure of angle 2 plus measure of angle 1 by substitution property. Subs prop equal. And now notice this, ready? I'm claiming that EBC's measure is equal to 2 plus 1, and I'm claiming that 2 plus 1 is equal to dBA. Therefore, let's say the measure of angle dBA is equal to the measure of angle EBC. What property did I apply there? I applied transitive property. But you also could have argued that it was a type of substitution. You also could have said, oh, I replaced measure of 2 plus measure of angle 1 with that. Transitive is a type of substitution. Yeah. Wow. Good sneeze. I'm so glad I get my sneezes on audio, like, recording now. I just want to, like, make a mixtape of, like, albums where, like, I digitally synthesize all my sneezes together and, like, then, like, can play them in sequence at different pitches. All right. By the way, I give Liam and Ryan full copyright access to any of my audio on my YouTube videos to turn into dubstep songs or anything of the sort. So there you go. Now I think that's legally binding. I also want to show, we just said this. There's one more thing I could say. I could then say that the angle dBA, this is going beyond the problem, is congruent to angle EBC. And I just want to show that to us because this will be a common reason we give later. The reason is def of congruent, or def of cong. I'll write it out because we'll abbreviate it every other time. Definition of congruent, and it's technically congruent angles. All right, but I usually, whether it's definition of congruent segments or angles, I'm fine with either. Let's see, I think I'm going to time out for there today. The other proof is about segment addition postulate with similar substitution, and I'll leave it at that. Thanks for watching, Internet friends. Bye-bye.